Hello everyone. Now today we're going to introduce some differential operators on vector. Okay, vector analysis. Now differential operator. The differential operator is denoted by del. Then we call it as a del symbol, and it is defined by del equal to I dou by dou x plus j dou by dou y plus k dou by dou z, where I, j, k are the unit vectors along x, y, z axis. Okay. Now these del operator, now differentiable operator, when I apply on the scalar quantity, how we going to affect it? When apply on vector quantity, I am going to apply how it happen, how we going to change it, that we going to learn it. Okay. Now first, gradient of a scalar function. If f is a scalar function, now f we don't have a directions. F here don't have a direction. That's why scalar function. Then f is a scalar function. Then gradient of f is denoted by like del f or grade f. We read it as a grade f or del f. Now that f we can apply for each deviation, like I dou by dou x along x deviation, j y deviation, k z deviation. Okay. I dou by dou x plus j dou f by dou y plus k dou f by dou z, which give for a gradient of f, that we call it as a del f. Okay. Now look at the problem, better you understood clearly. Now if f equal to x y square z square, then find the gradient of it. F at 1 comma 1 comma 1. First apply del operator on f is a del f, del, and f is x y square z square. Now this f we need to apply for each term. Okay. Now each term I apply here. Dou by dou x of x y square z square plus j dou by dou y of x y square z square plus k into dou by dou of x y square z square. Okay. Now this is a derivative along x now apply the derivative with respect to x here. Now x derivative is 1, now remaining y square z square plus along y derivative, now y square derivative is 2y, remaining xz square as it is, plus k into xz square as it is. Now z square derivative with respect to z is 2z. Okay. Now this is a del f. Then there is a gradient of f. They asked to find it at 1 comma 1 comma 1, at a point of 1 comma 1 comma 1. Now substitute the point here at 1 comma 1 comma 1. Nothing but in place of x substitute 1, in place of y1, in place of z1, substitute here. You can get for I plus 2j plus 2k. Now this is a way to find the gradient of scalar function. Find the Now look at the next example, that find the gradient of f and the mod of del f, at where f equal to x square plus y square plus z square minus 3xy at 1 comma minus 1 comma 2. Now del f equal to del is I dou by dou x plus j dou by dou y plus k dou by dou z and f. Now this f we need to apply for each term. Okay. Now I into dou by dou x of f. Now this we derive it with respect to x. Now x cube derivative 3x square. Now y cube derivative is 0, right? We don't have x term. Now z cube derivative is 0 minus 3xyz derivative with respect to x is 3yz, x derivative is 1. Now that's why minus 3yz plus j into dou by dou y of the total term. Okay. Now x cube derivative is 0, y cube derivative is 3y square minus 3xz, y's derivative is 1 plus similarly using for with respect to z derivative, now k into dou by dou z. Now this term 0, now this term 0 is 3z square minus 3xy. Okay. Now this del f we need to find it at point 1 comma minus 1 comma 2. Now substitute 1 comma minus 1 comma 2 here. Okay. And now in x place 1, y place minus 1 and z place 2. Substitute here in this expression. Then we have 9i minus 3j plus 15k. Okay. Now this is a gradient of f at 1 comma minus 1 comma 2. Now next we're going to find for mod. Okay. Okay. Now the mod is root of 9 square plus minus 3 whole square minus 3 whole square plus 15 square. Now 9 square is 981 plus 3 square is 9 plus 15 square is 225. Now sum it, you can get a root 30. Root 315. Okay, this is a way to find for the gradient of f and mod of gradient of f. Okay, now some of the two homework problems are given where f equal to x square plus 9 square at minus 2 comma 2 and where f equal to e power x sin y at log 2 comma pi by 4. Okay, now this del operator when I apply on the vector function, how are you going to change it? Then I want to look at that now. Next, the del operator when I apply on the vector function. Now if f is f1i plus f2j plus f3k. Now when the del operator apply on the vector function, then we can operate the two vectors, right? Now del is a vector and f is a vector. Then we can have two ways to apply it. First one is using of dot, second one is using of cross, right? Now if you using of dot, that known as a divergence of a vector function. If you use for a cross, that we known as curl of a vector function. Okay, now let f equal to f1i plus f2j plus f3k is a differentiable vector function. Then the divergence of f bar is denoted by div f or del dot f, both are same. It is denoted by div f equal to del dot f. Now del is I dou by dou x plus j dou by dou y plus k dou by dou z. Now if we have the component along x axis f1i, along y axis is f2j plus z axis f3k. Now how are we going to apply for dot product? Simply this is the way, right? Now I dot I is 1, remaining combination is 0. Therefore dou f1 I by dou x plus dou f2 by dou y plus dou f3 by dou z. Now find the deviation along x by z for f1, f2, f3 respectively. You can get the divergence of f. Now look at the curl. Okay, look at the curl definition. If f equal to f1i plus f2j plus f3k is a differentiable vector function, then curl of f is denoted by curl f or del cross f and it is denoted by defined by del cross f equal to the cross multiplication of the two vectors I, j, k. The one vector is a del have for the components here for along x, y, z is dou by dou x, dou by dou y, dou by z, like dou by dou x and dou by dou y, dou by dou z. Now for f is f1, f2, f3, f1, f2, f3. Now this determine, find it to get a curl, right? I into this row and column related, then dou f3 by dou y minus dou f2 by dou z, right? Minus j times dou f3 by dou x minus dou f1 by dou z plus k times dou f2 by dou x minus dou f1 by dou y. Now these are the definitions for a grade and a dive and curl. Next class I am going to discuss some of the problems on dive and curl. Okay, thank you.